So once we've factored it to this point, basically we've done everything that we learned was brand new as of yesterday. But then we look to see, can we factor these further? And you'll notice actually we can. I know it's not x to the second minus a number, but when it's x to the fourth, we can still do it. It just ends up being a couple x to the squareds on the inside. And I can still do it because it's minus a perfect square. So in this case then, the minus 1 becomes minus 1 plus 1. And the minus 16, it becomes minus 4 plus 4. So having done that, can we factor it any further? Yes, even still. Because you'll notice that here we have x squared minus a perfect square coming up a couple times along the way again. And so both of those are going to factor down. What makes this problem especially challenging is that it can just keep going. Now, are you going to have to be doing a ton of these? No, but I want you to see that it can be done, that we can encounter problems where it will factor down even more than maybe some that we've previously looked at. Now then, into some newer work for today. We're going to be finding the zeros of polynomial functions today. Now when we say find the zeros, remember the zeros are the things that I can plug in for x that make the whole equation equal 0. Well, just like when we were dealing with a factored quadratic, where we had two sets of parentheses, we had set each of those parentheses equal to 0. We can do the same thing here. I want to know what I can plug in for x plus 1 that will make that equal 0. And what would that give us? Negative 1. So x could equal negative 1 to get that, because I'm subtracting the 1 from both sides there. And then I go to the next parentheses, the x minus 5. And I want to know what would make that equal 0. It's got to be a positive 5. And then I go to the x plus 6. And I'm setting that equal to 0. Which means we also have a 0 of negative 6. And so those are all of our zeros. Is taking each of those terms and seeing what can I plug in for x that makes it equal 0. And those are the zeros of the polynomials. We did it before with quadratics. Now we can see we can do it with a factored polynomial as well. So having done that one, go ahead and repeat the process. Do the next three, please. Oh, and you don't have to list duplicates. All right, and then we go and we do the second one there. And again, I'm trying to find the 0, so it's what makes each of the parts equal 0. And, you know, like the x minus 2 equals 0, basically setting each of the parentheses equals 0, which we can do, but then what about that x that's sitting out front? What do we do with that? Well, because it's multiplied by the whole thing, we treat it the same. I say that x equals 0. It's just that there's no adding, subtracting, or anything like that to do to both sides to know what to plug in for x. X equals 0 there. So one of our answers is 0, because if I plug in 0 for x, 0 times that whole thing is going to give us 0 still. So for number 2, second one at least, that's what you should be looking at. Alright, now let's take a look at the third one. With the third one, remember you don't actually have to list the duplicates. When I see x minus 8 squared, remember that means x minus 8 times x minus 8. I just want to know what is going to make x minus 8 equal 0. Because whatever makes it equal 0 is going to make it equal 0 after I square it as well. So that ends up giving us x equals 8. Then we do the same thing with the x plus 7, setting that equal to 0. So you should just get x equals 8 and negative 7. Now you could list them separately if you wanted to. You could list the repeats. Some people will do that. That's fine. If you did that, you'd have 8, 8, negative 7, negative 7, negative 7. You'd have to have 1 for every exponent that shows up here. Then on to that last one. Again, it's setting each of those parts equal to 0. So the x plus 4 is actually the easiest one to set equal to 0. Before that, notice we have 3x squared equal to 0. Or you could just treat it just as 3x, because again the squared isn't going to change anything. And then for the last part, it's going to be 2x minus 5. Then we're trying to figure out what makes it equal 0. Well, for that first one, 3x equals 0. 3 times what is 0? 0. So that gives us one of them at 0. Okay, the x plus 4 equals 0. Okay, so we subtract 4 from both sides. So yes, it's negative 4. But then for that last one, 2x minus 5 equals 0. Whereas the other ones, you probably were just doing them pretty quick in your head. This one, maybe, maybe not. Most people will actually add 5 to both sides and then divide by 2 in order to get this. So you end up getting x equals 5 halves, or 2.5, or 2.5, just depending on how you chose to write it there. Any of those would be fine for that. So now we dive into these types of problems. These problems are actually the same skill as what we just did. The difference is that here it's telling you the zeros, and it's asking you to now write the function that would give you those answers as zeros. So your answers here should each be polynomials, like the last set of original problems were. So for instance, with this first one, I know I want zeros of negative 3, negative 2, and 1. So I'm going to have, well, how would I get an answer of negative 3? What would be inside the parentheses? It'd have to be x, it'd have to be 3, and it'd have to be a plus 3. Yes, because that's what makes plugging negative 3 in, makes that equal 0. We do the same for the other two. This is the answer you should be getting for that first one. And having seen that, it should be pretty good cruising through the rest, because they're all going to be the same idea. For the second one, when I just start plugging those in, the 0 might have thrown you off a little bit. Remember from the last set of problems that we did, when it was just a plain old x with nothing added or subtracted to it, it just gave us 0. So that's why it's just plain old x. But I don't really like leaving it stuck in the middle like that. That's not the way that we normally would leave such a thing. So instead, I'm going to put that x first, just because when we have an x that's by itself, that's where we tend to leave it. So this is what I'm looking for your answer for that second. And then you can check the last of them. Notice that when the number was repeated as a 0, that meant that we needed to include that exponent to show why it would have been repeated. So now today we're adding one more layer. We're going to be seeing how to solve some of these equations that are more complicated than just a quadratic. But this one, I hope, looks familiar to you. This is the very first problem that we started with at the start of class today. I gave you this part and I said to factor it. When solving one of these problems, the very first thing we do is to factor it. And so in working this problem out, the first thing I do is I factor as much as I possibly can. All right, so now that we see what the factored form is, and yes, normally you'd have to do that work afresh. It just happens that in this case we already had that. We're now looking to see what can I plug in for x that makes it equal 0. And just like we were doing with the previous problems, it's basically saying take each set of parentheses and set it equal to 0. Now most of those you're just going to do quickly and easily in your head, right? So like x minus 1, what would that be? That give us a 1. I don't even necessarily have to write out that equation to do it. What about the x plus 1? What's that going to give us? That's negative 1. Okay, great. Next up, though, we hit x squared plus 1. That has to equal 0. Now, this one actually is a little bit trickier. Because if I have x squared plus 1 equals 0 and I try to solve that, I'd have, subtracting 1 from both sides, I'd have x squared equals negative 1, which means that x equals the square root of negative 1. Technically the plus or minus square root of negative 1, but I'm not going to worry about that at the moment. Because I just want us to remember, what's the square root of negative 1? I. It's an imaginary number. I don't want to deal with imaginary numbers on this. By default in math, it's assumed that the question is asking for the real solutions. You only are going to get into imaginary solutions if a problem specifically says to include imaginary or complex solutions in general. So because that would give me an imaginary number, I'm just going to have no solution from that particular parentheses. So I basically just skip over it because it couldn't even factor down further. And that's how you can know. If it doesn't even factor down past that, it looks like you're looking at something that doesn't give us another solution. So then I continue on to the next one. And I say, what minus 2 would equal 0? Well, that would give me a 2. And then I go to x plus 2 equals 0. Well, that would be a negative 2. And then I go to x squared plus 4. Notice it's a plus 4. I can't factor it. The reason I can't factor it is because the solutions are imaginary, so it doesn't give us anything. So those 4 solutions are our only real solutions, but the only solutions we're worried about right now then.